Hello, Algebra 2. In this video, we are looking at Chapter 10, Lesson 5, which is the Law of Sines. So a sailmaker is designing a sail that will have the dimensions shown in the diagram. Based on these dimensions, the sailmaker can determine the amount of fabric needed. The area of the triangle representing the sail is half times base times height. Although you do not know the value of h, you can calculate it by using the fact that sine of A equals h over c, or h equals c times sine of A. And so when you write the area formula, you will just substitute c times sine of A in for your h. Helpful hint: an angle and the side opposite that angle are labeled with the same letter. Capital letters are used for angles and lowercase letters are used for sides. So for this triangle, here are the equations that you will want to write down for the rest of it. But you can see that angle B here is across from side B and so on. So just remember that. Okay, example 1. Find the area of the triangle, round to the nearest tenth. And so here we would write the area formula. So A equals half times A, and then times B sine of C. And then substitute 3 for A, 5 for B, and 40 degrees for C. And then use a calculator to evaluate, and that gives you approximately 4.82. Okay. Another example, find the area of the triangle. So here the area is written for us. So then it would be half, and then substitute 8 in for A, and then 12 in for C, and then sine of 86 degrees. And then when you calculate that, you'll get approximately 47.88. So the area of your triangle is about 47.9 meters squared. The area of triangle ABC is equal to half times B times C times sine of A, or half A times C sine of B. By setting these expressions equal to each other, you can derive the law of sines. And so here it's just showing you the work that you have to do to get to your law of sines. And down at the bottom of the table, that would be good to write down for your notes or print off. And so your sine of A over your A equals sine of B over your B, and then sine of C over C. And remember, your uppercase letters are your angles and your lowercase letters are your sides. The law of sines allows you to solve a triangle as long as you know either of the following. Number 1, 2 angle measures and any side length, which is angle, angle, side, or AAS, or angle, side, angle, or ASA information. Or number 2, 2 side lengths and the measure of an angle that is not between them, which is side, side angle, or SSA. Another example, solve the triangle and round to the nearest tenth. Step 1, find the third angle measure. So you're going to take your angles that you know, and we know that a triangle adds up to 180 degrees on the inside. So we know that one is 33, and we know that the other is 28, and then we set that equal to 180. And so if we add the 33 and the 28 and subtract that from 180, we know that the last angle is 119 degrees. So step 2, find the unknown side lengths. So we do the sine of D, which is our angle, over D, our side length, equals sine of F over F. So we know sine 33 over D equals sine of 28 over 15. And then you cross multiply. And then when you solve that, you get D equals 17.4. And then you do the same thing for your E and you get 27.9. Okay, let's do this one together. Number 1, solve for the third angle measure. And so we would do 180 degrees minus 36 minus 39. And that gives us 105 degrees. Okay, step 2, find the unknown side. So if we plug in what we know, we have sine of 105 over 10 equals sine of 36 over q, which gives q equals 10 sine 36 over sine 105, and that is approximately 6.1. And then on the other side we have sine of 105 over 10 equals sine of 39 over r. And then when you plug that in, you get r equals 10 sine 39 over sine 105, which is approximately 6.5. And you can write it out the long way too and multiply it out that way too, but this is just a simpler way to write it. When you use the law of sines to solve a triangle for which you know side-side angle information, 0, 1, or 2 triangles may be possible. For this reason, SSA is called the ambiguous case. And so at the bottom, the table is just some more information on that. So that would be a good thing to print out or write down. Solving a triangle given A, B, and the measure of angle A. Use the values of A, B, and the measure of angle A to determine the number of possible triangles. If there is one triangle, use the law of sines to solve for the unknowns. If there are 2 triangles, use the law of sines to find the measure of angle B1 and B2, and then use these values to find the other measurements of the 2 triangles. And then remember, when one angle in a triangle is obtuse, the measures of the other 2 angles must be acute. Example 3, determine the number of triangular banners that can be formed using the measurements A equals 50, B equals 20, and measure of angle A equals 28 degrees. Then solve the triangles, round to the nearest tenth. Determine the number of possible triangles, in this case, for step 1. So we know A is acute, because it's only 28 degrees. And so because B is less than A, there is only one triangle possible. Step 2, determine the measure of angle B. So if you do sine of A over A equals sine of B over B, and plug in the numbers that you know, then you get your sine of B to equal 0.188. And let angle B represent the acute angle with a sine of 0.188. Use the inverse sine function on your calculator to determine the measure of angle B. And so the measure of angle B equals the inverse sine of 20 sine times the sine of 28 degrees over 50, which is 10.8 degrees. So your measure of angle B is 10.8. And then step 3, find the other unknown measures of the triangle and solve for the measure of angle C. So we know that A is 28 degrees, B is 10.8, and the total is 180. And so you just subtract the 28 plus the 10.8 minus, or from the 180, and you get measure C to be 141.2. And then you want to solve for C, the side length. So you plug in what you know to this formula right here and solve, and you will get 66.8. Another example, determine the number of triangles may conform using the measurements A equals 10, B equals 6, and measure of angle A equals 105. So step 1, determine the number of possible triangles. In this case, angle A is obtuse, and because B is less than A, only one triangle is possible. Step 2, determine the measure of angle B. So we're going to use this formula again and plug in what we know. So we know that the sine of 105 over 10, and then sine of B over 6, and then solve, and that will give us 0.58. And let angle B represent the acute angle with a sine of 0.58, and use the inverse sine function on your calculator to determine the measure of angle B. And so when we do that, our measure of angle B is 35.4 degrees. And then step 3, we need to solve for the measure of angle C, and that will be 39.6, and then solve for C using this formula, and then when you write it all out, you get C equals 6.6.